Okay guys, I'm going to go ahead and real quickly go through the speed section of the semester final review. Speed equals distance divided by time. If Billy travels 40 miles in 2 hours, what is his average speed? Your distance is going to be 40 miles. Your time is going to be 2 hours. Your unknown is his speed. So speed equals distance over time equals 40 is our distance divided by 2, which is our time, gives us a speed of 20 miles per hour. 20 miles per hour. Okay. If Anne walks to her house, which is 100 meters, that's a distance, away at an average speed of 5 meters per second, so 5 meters per second is my speed, how long, that's time, did it take her to get to her house? All right, so we're going to use our triangle for this. Okay, we have speed equals distance divided by time. Okay, this time I want to solve for the time. I'm going to cover the t. I'm left with distance divided by speed. Okay, my distance was 100. My speed was 5. 100 divided by 5 is 20. What are our units? Meters per second. Sorry, meters. No, seconds. Time. 20 seconds. Number 4. If Bob travels for 30 minutes, that's a time. At 2 meters per minute, that's a speed. How far? That's a distance. How far did Bob travel? So this time we want to solve for D. Okay, if I cover up D, I'm going to have the speed times the time. My speed is 2 times 30 equals 60 meters. 60 meters on that one. All right. Graphing. In which section of this graph is the speed constant? We have a distance time graph. Okay, if you remember way back when, if we have a straight line, straight diagonal line on a distance time graph, that represents constant speed. Okay, so we have constant speed in section A. He's not moving at all. He's at rest in B. But we have constant speed in section C and constant speed going the opposite direction for section D. In which section of this graph is the speed 0? That's going to be section B. A flat line means he's not moving, so his speed would be 0. In which section of this graph is the object moving the fastest? Well, we could sit there and do the math, or we could just look for which line is the steepest, all right? This line is not real steep. This is definitely not steep. This one is pretty steep, okay? It's steeper than this one. How do I know that? Because he goes 30 yards from the 10-yard line to the 40-yard line in 20 seconds here. Okay, if I were to do the math there, that would give me, he goes 30 yards in 20 seconds. That gives me 1.5 meters per second. Okay, in this section, he's going 40 yards, right, from the 40-yard line down to the 0 in 40 seconds, from the 60 to the 100 second mark. So that's 40 seconds. Which gives me 1 meter per second. Okay, so you could either do the math, or you can just look for the line that is the steepest. The steeper the line, the faster the object is going. So that would be section C. What is the speed of the object during the first 20 seconds? You are going to need to know how to do this. So he goes 10 meters in 20 seconds. Your speed is 0.5 meters per second. What is the speed of the object during the second 20 seconds? Well, we said he's not moving, so it's 0. What is the speed of the object in section C? Okay, we just calculated that. We said that was 1.5 meters per second. And in section D, we calculated that too. We said that was 1 meter per second. If y'all have any questions about speed or graphing, and you will need to calculate speed from a distance time graph, and you'll also need to know which objects are going fastest and slowest and at rest, ask me if this does not clear it up for you.